Continuing on with our test review, we are at number 26, which is basically adding vectors together. They are going to specifically do vector u plus vector v. Vectors are things that have magnitude and direction, so we got arrows on them for the direction. U is going from the origin up to that point, so it's that. V is going from the origin up to that point. Vectors don't really have locations, but they do have a standard position. The standard position is when you put the tail end of them at the origin. The way you add vectors, if I just do some random vector here and some random vector there, you add them kind of like if you take a walk somewhere. If you take 10 steps that way and 7 steps that way, it'd be the same thing as cutting across and going from there to there. They call it adding head to tail. That's how you add them together. So if I add u plus vector v, because vectors don't really have locations, I could take this v vector right here and I can move it up here as that dashed line. If I put an arrow there, that one with the dashed line is also vector v. I just moved it. And right here would be the head to tail part. And that would be the same thing as walking from here and walking across the field that way to that location. So I'm going to use purple, and I'm going to draw, hopefully I can get it close enough, what is a lot of times called the resultant vector u plus v. So that's what they labeled as w in the course that I'm actually looking at. Just drawing a little bitty arrow on top of those to indicate vector. I could also start with vector v and move vector u over to here. So this one here is also u. And I could have done the same head to tail thing with this being the head to tail corner. And either of those, whether I went down here first on the lower one and then walked up that way, or whether I went up this way first and then that way, they both put me at this point right here. So our end location would have been right up here at that point right there. So that's how you add vectors visually. As for how you actually do the vectors, they give you in the course that I have that u equals a comma b. My a is the x position, and if I look at vector u, if I dropped a line down to about here or so, that length right there would be a length of a, and if I came directly over here this way to about there, that would be a y value of b. Kind of missed with that. It's hard to draw with the little finger being the brace. But if I go a units in the x direction, b units in the y direction, it puts me right there. And that's the vector u, which is why they label it a comma b. Same reasoning. I'm not going to draw it on here, but cd. If I took my v and I came down this way, it's a value of c. That location roughly is a value of d. And that's why vector v would be c comma d. Because if I walk c units in the x direction, d units in the y direction, it'd put me at that point, which is the end of v. So anyway, we have those and we have to add the vectors. When I add the vectors, all we do is add the x components and add the y components. And abbreviate. You add the x components and you add the y components. Our x components up here, this is x comma y. I did the angled vector line. They did not do the angled vector line in the book that I have. I don't know how they'll do it on your actual test. A lot of times, if you know that you're doing vectors, a lot of times they just write it that way there as if it's the end point, and that's just fine. They're kind of interchangeable notation depending on the course. You're not doing linear algebra in this stuff. If you were, that might have a different meaning when you hit that course. We're not doing it. But if I looked at it and said, well, let's treat this vector here, that u plus v vector, I put a dot there as if it's the end dot. I could look at this vector the same way. This point right here would be the point c comma d. Now if I went from the origin to the point c comma d, it would be the v vector. If I went from the origin to the point A comma B, which is what that ordered pair is, from the origin to there would be written as a vector that way. So a lot of times you can just treat a vector as if it's its end point. It's the head of the vector point. Right, so a lot of times you can do that. I'm just going to leave it there. So anyway, if I add the x components, x comma y, our x components are the a and the c. And that's what we would get for the x component. It's a comma, not a 1. If I add the y components, xy, it's the b and the d. So we would just add those together. On my study guide, that is, oh, then I got to get the magnitude of it. So that there would be this point right here in purple. That would be the point, comma, a plus c, comma, b plus d. That would be the point right there. I can kind of see I didn't measure, but if I add that length and this length together, it's going to put me about here. I'm probably a little bit short on the A. Over here, somewhere about there, so would be B plus D. And that kind of means that that dotted length there, if I did that, if I just redrew this whole thing, I'd pretty much have a triangle. The length of this side of the triangle would be the A plus C units that would be going when I'm at A units and then added that many to it. So I take that length and tack it onto the end. Close enough, we got the A plus C. If I take this length and tack it on up here, it puts us at B plus D. And they're looking to get the length of this hypotenuse. I kind of hesitate to use the same letters they use in the Pythagorean theorem because they always write the Pythagorean theorem this way, a squared plus b squared equals c squared. Well, these a's, b's, and c's are not the same as these a's, b's, and c's. So I'm going to write this as an uppercase. I'm going to write this as an uppercase, then I'm going to get to the c and say, oh my god, uppercase c is the same shape. So I'm just going to call it a r for result. If I want the length of this, I have to do the square root of both sides. That square root, this gives us the length of that hypotenuse. That capital A is this part right here. Capital B is that part. So I know I'm doing square root. I'm going to add my x components, or just get the x component of the vector in question, y component of the vector in question, and that's what we do for this, which would be the magnitude of W. Vector talk, they do a double line thing for magnitude. And you do it that way to signify magnitude. It's just the length of the vector. So the length of that there. It's not really a hard thing if they give you numbers. Like just real quickly, for example. I'm just going to make up one. I'm going to give us a 4, 3. If we go from the origin to the point 4, 3, then we have that vector. That is that vector. I didn't label it as a vector there, but it's the R. It's the W. That's the W up there. If I wanted to get that length, I could look at this and say this is, ooh, it's just that. It's just the a squared plus b squared equals c squared. How would I get that length? I'd say, well, this length here is 4 units. This length is 3 units. I'd square root both sides. So I'd say we have the square root of 4 squared plus 3 squared. And when I did all the math on this, I get a 5 out of it for this. But you just get the vector you're looking to get the length of, take its x component squared, its y component squared, that's the x component squared, that's the y component squared. If you flop the order, it does not matter, because commutative property of addition. So they asked us for the length of W. Can't remember if they called it length or magnitude. It says length. The length of the W vector, once we have this as the W vector, x component is a plus c, y component is b plus d. We're adding the vectors, so we just added the x's, added the y's. Once we have this vector, we just say we're going to square that, we're going to square that, we're going to add them and square root it. That's just your distance formula for distance between 2 points. So that's all it is. Anyway, that was number 26. And this would have been answer choice something or other. Which one would it have been? Oop, minus sign, plus sign, answer choice A. Did not change their numbers. That is answer choice A on number 26.